everyone, and welcome back to this brand new lesson. And this lesson is a bit different from the previous exponent ones in the fact that the exponents have variables in them. See, the exponents are not only numbers, they are now actual variables, and the bases are all numbers. Okay, so there are two of these types where we only need to multiply and divide. Can you see there's no pluses and minuses here? So there's no brackets, no powers and roots. There's just division and multiplication. Okay, so that is the first type. The second type is where we need to factorize first. Now, why do we need to factorize? Because the numerator has more than one term and the denominator has more than one term. When there are more than one term in the numerator or denominator, or more than one term in both, we must factorize. Okay, so there's pluses and minuses there, so we are going to have to factorize. And I'll show you once we get there that there's a quick and easy tip for that. Now, we want to simplify the numerator and denominator before we divide. Okay, so we want to get as far as possible and make this as small as possible and this one as small as possible before we do the actual division. So simplify your numerator and the denominator as far as possible before we start to divide. But to multiply, now we are multiplying here and there, right? So, but to multiply when there are exponents, we must have the same basis. I cannot multiply the 9 with the 12 because they have exponents, and to do that, these bases must be the same so that we can add the exponents, right? But the 9 and the 12 is not the same. So what we're trying to do is we're trying to make these bases into similar numbers. Okay, so we want to change the bases to the product of their prime factors, which is step number 1. Now, I can change a 9 to its product of prime factors. Now, if you can't remember that, most calculators have the function as well, where you just simply press 9, you press equal, then you press the button shift, and you find the small button that says fact. And you press that and you'll see it ends up with the following. It will give you a 3 to the power of 2. Now, that is the product of prime factors. Now, there's a long way as well. You simply draw this T table like we did in grade 9. And you write the 9. You divide by the smallest prime number, which is 2. But I can't because it doesn't give me, it gives me a fraction, not a whole number, right? So, we take the next prime number, which is a 3. 9 divided by 3 is 3. We take the 3 again until we end up with 1. So then we use 2, 3. So we write the 3. How many 2's did we use? 2 of them. Okay, so that's the long way. Now, once we rewrote these bases as a product of their prime factors, that 3 to the power of 2 is 9. But what about the exponent? We cannot just forget about it or throw it away. So we put this in brackets and we leave the exponent on the outside. So what is written here is exactly the same as there. Okay, multiplied by. Now 12 also has a product of prime factors, which will be a 2 to the power of 2 times a 3. Okay, because that gives us 12. It's 4 times 3 is 12. And what about the exponent there? We just simply write it as x plus 1. And then how about at the bottom? If we draw the line here, we will have 3 to the power of 3. That's 27. Leave the x times 2 to the power of 2 in brackets x minus 1. Okay, because a 4 is a 2 to the power of 2, and we have to write the exponent there. Please make sure that you rewrote these exponents as they were. Very important. And now, follow the exponent laws, because here we have powers. It's always done before multiplication, so it will be write the 3 and then it's the 2 times the x, which will be 2x, and 2 times minus 1, which will be minus 2. And many forget to do that. Remember, it's the exponent on the inside multiplied by the entire exponent on the outside. And because that's 2 terms, I'm going to have to multiply with both. So multiplied with, and I write the 2, and then I simply take that 2 multiplied with the x and multiply with the plus 1, which gives us 2x plus 2, and multiplied with 3, and don't forget it has an exponent 1, which get multiplied with the x and with the plus 1, which gives us x plus 1. And then we simply draw the division line here, and we do the same at the bottom. So it will be 3x times 2 to the power of 2x and minus 2, because 2 times x is 2x and 2 times minus 1 is minus 2. Okay, great. So far so good. Now, simplify the numerator and denominator as far as possible before division. Now, here is multiplication. There's a 3, there's a 3. So I can simply write the 3 and then I add the exponents. Now, 2x plus x gives me 3x. And minus 2 plus 1 gives me a minus 1. And then I rewrite everything that remains the same. So there we go. This will be 3 to the power of 3x times 2 to the power of 2x minus 2. And now I have only division left because I simplified the numerator denominator as far as possible. There's a 3 and a 3. So I write the 3. Then I take the top exponent, which is 3x minus 1. And I minus the bottom exponent, which is 3x. Okay, so there we go. Same with the 2, multiplied with write the 2. Then I take the 2x plus 2, which is the exponent here at the top. And I minus the bottom one, but there's something you have to remember here. Because I minus with more than one term, that is an expression. So I have to put this expression in brackets. So it will be 2x minus 2, because the minus will change that sign and that sign. So don't forget it. Don't just minus with the 2x and leave that a minus. If I minus with an entire expression there, both the signs will change. And then we just simply continue to simplify here. So we write the 3. 3x minus 3x is a 0. So it will be 3 to the power of minus 1 times, and then 2, we simply write the 2, and let's do all of this in one go. 2x minus 2x, because it's the minus times the 2x gives me minus 2x, right? So 2x minus 2x is 0, and then 2 and a minus times a minus is a plus 2. So then it will be 2 plus 2 gives me a 4. And we are almost done, because now we have to apply a definition, because that base has a negative exponent. So we put it below the line. So it will then equal to 2 to the power of 4 over 3 to the power of a positive 1. And that gives us 16, because 2 to the power of 4 is 16 over 3. And I am done. I don't have to simplify further than that. So that is the end of this. So quite easy. When we see that we have sum where the exponents have variables, we try to find out whether we have to factorize first. We don't need to, because there's no pluses and minuses in the numerator and denominator. It's just multiplication and division. So step 1, change the basis to product of prime factors, which we did with the exponents still on the outside, right? Can you see? Then follow exponent laws, which means the powers come before the multiplication. So multiply all the exponents with the exponent on the outside, and the bases stay the same. And then do the multiplication by writing the base, adding the exponents of the same bases that I multiply. And then when we divide, same basis, we write the base, we minus the exponents. We write the base, we minus the exponents, right? Until we end up with our final answer. So I hope you could follow. It's not that hard. So let's quickly go and look at the type 2. Now, what's the difference between this one and that one? Here we have minuses and pluses in our numerators and denominators. So we need to factorize. Now here is a small little tip. We want to take out a common factor. So this cannot be a common factor with that, because that is 2 to the power of x plus 2 and that is 2 to the power of x plus 1. They're not the same thing. Same as at the bottom. That's 2 to the power of x and this is 2 to the power of x plus 2. Not the same thing. But here's the little tip. You go to the exponents and you go to the variable exponent, which is x, right? Now at the front of this x, you look at that coefficient. What is that coefficient? It's a 1, right? A 1 is the number in front of a letter. So there's a 1, whether you see it or not. Now, there is also a variable x, and look at it's a coefficient. That's also a 1. So they have the same coefficients, and the bases are also the same. That means a common factor exists. Please listen one more time. If the bases are the same and the coefficients in front of the variable exponent is also the same, a common factor exists. Now look at the bottom one. There's a 2 and a 2, so same basis. That coefficient of the x is a 1, and that coefficient of that x is also a 1. So a common factor exists. You cannot see it yet, but I'll show you how to do it. Now please don't forget that a 2x times a 2 to the power of 2 is the same as write the 2, add the 2 exponents. So x plus 2 stays a x plus 2, right? So we can also work in reverse. So when the bases have exponents that add up like this, because we cannot write 2x, then we multiply it. We cannot add an x with a 2, so we just simply write it like this, right? So if we work in reverse, that is basically a 2 to the power of x times a 2 to the power of 2. This is law number 1 in reverse, right? So let's just break this up. So basically this will become a 2 to the power of x times 2 to the power of 2. And go and check, because 2 to the power of x times 2 to the power of 2 is write the 2, x plus 2, x plus 2. See, that's the same as that. Then we write the minus, and we do the same here, which will be 2 to the power of x times 2 to the power of 1. Because 2 and 2, write the 2, x plus 1 is x plus 1. See, that is the same as this one. The minus is the same, that is the same as that. So I didn't change anything, I just used the law in reverse. Then we divide with, this will be 2 to the power of x plus 2 to the power of x times 2 to the power of 2. And this is exactly the same as that, because a 2x times a 2 to the power of 2, or a 2 to the power of x times a 2 to the power of 2 is simply write the 2, x plus 2, and look, x plus 2. Okay, so it's law number 1 in reverse. I didn't change anything. I just rewrote it in a different way, in a reverse of law number 1. So now, look at the top part. What is in common in that term that's also in common in that term? The 2 to the power of x. So take out the 2 to the power of x and then open up brackets, because we're busy with a common factor. So that term divided by 2 to the power of x is just a 2 to the power of 2. Okay, that's what's left. Minus. And then we take that term divided by the common factor. So 2 to the power of x times 2 to the power of 1 divided by 2 to the power of x. They will cancel out, and this just a 2 to the power of 1 is left. Okay, wonderful. And at the bottom, let's look at the two terms. There's a common factor in this one and in that one, which will be 2 to the power of x. There's a 2 to the power of x, so take it out. So this will be 2 to the power of x, open up brackets, 1 plus 2 to the power of 2, right? Because that term divided by the common factor is a 1, and that term divided by the common factor is that. And don't forget about the plus in the middle, right? Okay, so now we have one term, so we can start to divide. So that one and that one gets cancelled because they're exactly the same thing. And this equals to 4 minus 2 at the top, and at the bottom we have 1 plus 4. And that equals to 2 over 5. And I am done. Okay, because now we just have numbers left. And see, that's how we simplified this one. Way easier, right? So what do you have to remember here? If we have pluses and minuses and our exponents have variables, we are trying to factorize, because we have to factorize when there's more than one term in the numerator and in the denominator. So look for a common factor. How can we find them? We check if the bases are the same, and then we check the coefficients in front of the the variable in the exponent, and that's a 1 and that's a 1. What does it mean? Split this one up with law number 1, like the back or the reverse of law number 1, and then we end up with that. Take out the common factor. Make sure you rewrite what is left after we take out the common factor in each term. Divide, and then we have the final answer. Easy enough. So let's go and try some more examples. Okay, now here are some examples that you need to try. Now again, just quickly look here. There's no pluses or minuses, so this is just multiplication and division. So again, we rewrite these big bases into their prime bases, and then we just follow our exponent laws, right? And here, what do we need to do? There's a minus there, so basically we need to take out a common factor. We need to factorize, we have to. There's also pluses and minuses, so we are going to take out a common factor and factorize. So that's the little tip I have for you. Give them a go and see if you can get this done. There's a little bit of a catch there, and I'll show you once I get there, but see if you can figure out how to get a common factor between those two. Okay, great. So let's continue. Now in this example, and I'm going to quickly go through this, this will simply be a 2 times a 5, and we have a 2x plus 3 times 2 to the power of 2, and we have a 1 minus x. And at the bottom, we've got a 5 to the power of 2, 2 plus x. I just rewrote all of these big bases into their product of their prime factors, right? And don't forget about the exponents. Then this will become 2 to the power of 2x plus 3 times 5 to the power of 2x plus 3 times 2 to the power of 2 minus 2x, because remember, it's that 1 times that times that. It's this 1 times that, and it's that 2 times that, right? So make sure you multiply correctly, and at the bottom it will just be that 2 times that 2 and the x. So we will have at the bottom a 5 to the power of 4 plus 2x. And now keep simplifying at the top. Well, there's a 2 and a 2 that we need to multiply. So I write the 2 and I add the exponents. Well, 2x minus 2x is a 0. And 3 plus 2 is a 5. So 2 to the power of 5. And I have here a 5 to the power of 2x plus 3. And at the bottom, a 5 to the power of 4 plus 2x. Now, let's continue. Equals. This gives me 2 to the power of 5 times. We write the 5 because now we're going to divide. So we simply write the base and we minus the exponent. So it will be 2x plus 3 minus 4 plus 2x. Remember, we're minusing with two terms here, so both terms in brackets, so the minus can change both signs. So this will be 2 to the power of 5 times 5. Now let's do this all in one go. 2x minus 2x, because a minus times a plus 2x is a minus. So 2x minus 2x gives me 0, and then 3 minus 4 gives me a minus 1. And then I end up with the following: 2 to the power of 5 over 5, which is 32 over 5. And I am done. Okay, great. So work through this example and see if you can get the same answer as I did if you got it wrong. Now, how about the next one, which has a small little trick in it? Because we have to factorize here because there's a minus in my numerator. So look again, I cannot find a common factor yet because the bases are not the same and the coefficients there are not the same. But if I take that 9 and I rewrite it as 3 to the power of 2. Put it in brackets n plus 1. See, I just rewrote the 9 as a product of its prime factors. And then at the bottom, I'm going to rewrite that 72, which is such a big number. And I'm going to write that as a product of its prime factors. So that will be equal to 2 to the power of 3 times 3 to the power of 2 in brackets to the power of n. Okay, so don't forget that basically 72 is 8 times 9, and that is how I got the product of prime factors. By typing 72 into my calculator, I press equal, I press shift, I press the button fact, and it gives me this as an answer. So now let's continue. I also didn't have to write that multiplication. I can just put a dot like I did before, just put them against one another. So this will become 3 to the power of 2n minus 3, and then it will be 2n plus 2. So 2 times n is 2n, and 2 times plus 1 is plus 2, and at the bottom we have 2 to the power of 3n times 3 to the power of 2n. Well, instead of the multiplication sign, I just put the dot. Okay, there we go. Now, same basis, same coefficients, and because that one is 2 terms, I'm going to split that one up. Don't forget about that. It's small things that you have to remember. So that's the same as that. Am I right? Because 3 times 3, right? The 3, 2n plus 2 is 2n plus 2. So I just rewrote that as law number 1, the reverse, right? And then draw the fraction line, and then we have at the bottom a 2 to the power of 3n times 3 to the power of 2n. Take out the common factor at the top, which is now a 3 to the power of 2n. Leave in brackets 1 minus 3 to the power of 2. And at the bottom, we've got 2 to the power of 3n times 3 to the power of 2n. Those two are the same. They can cancel. I can cancel now because it's one term divided by one term. They're the same. And then I basically have the following left. 1 minus 9 equals a minus 8, because 3 to the power of 2 here is a 9. 1 minus 9 is a minus 8. So it will be minus 8 over 2 to the power of 3n, which can be used as the final answer, but we can also rewrite it as minus 2 to the power of 3 over 2 to the power of 3n, which gives us a minus, and we write the 2, 3 minus 3n. So basically the 8 becomes a 2 to the power of 3. Because the bases are the same, we can write the base, don't forget about the minus, and then it will just simply be 3 minus 3n, and there we go. But this will be sufficient for the final answer, I am sure. So great, this is an easy example too, a little bit tricky here towards the end, but that's the whole idea when we solve these problems that have a minus or a plus in the numerators and denominators. We have to factorize. Now how about this final question? Now here in this one, now basically I'm just going to come back to this. This is a little bit tricky for grade 10, so please don't feel too hard up if you struggle with this one. Just work through it and you'll see why we did what we did, because we want the bases to be the same with exactly the same coefficients in front of this n variable, so that we can take out a common factor in the end, like here at the bottom. Now how about here at the top? Here we have a plus and a minus. We're going to have to factorize. And look, there's a base 3, there's a base 3. The coefficient there is a 1 and a 1. So we're basically going to split that one up. Here we have a 3 and a 3. Coefficient is a 1, coefficient is a 1. We split them up and we take out a common factor because we have to factorize. Easy enough. So this will be 2 times 3 to the power of x plus 3 to the power of x times 3 to the power of negative 2. Please don't forget that, because the 3 to the power of x times 3 to the power of minus 2 is right. The 3x plus minus 2 is the same as x minus 2. And then here at the bottom we have 5 times 3 to the power of x times 3 to the power of 1 minus 7 times 3 to the power of x times 3 to the power of negative 1. We simply split these up so that I can take out a common factor, right? Okay, great. So, because the 3 to the power of x plus 1 is not the same as 3 to the power of x minus 1. But if we split them up, I've got a common factor there. That's why I told you, go and test if the bases are the same that have the exponents that are variables, and look at their coefficients too. If they're the same, split them up, and then we have a common factor. The same as up here. There's a 3, and on this side is a 3, same basis. same coefficients of the x variable, which is in the exponent, and then we know we're going to split that one up and we will have a common factor between them. So let's take out the common factor here, which will be a 3 to the power of x, and then we have a 2 plus 3 to the power of negative 2 divided by, and at the bottom we have also a 3 to the power of x, and then what remains? A 5 times a 3 minus a 7 times a 3 to the power of negative 1. Okay, great. So far so good. You understand how the common factor works? I hope you can remember that. So equals, and now one term, we can divide those two, and then we simply have a 2 plus 1 over 9 divided by 5 times 3, which is 15, minus a 7 times, and that's 1 over 3. Now, don't struggle with all of this. You can simply do it on your calculator exactly the way it is written there. So, I'll just go step by step. So 2 plus 1 over 9, it gives me 19 over 9 divided by, and then we simply take the 7 times the 1 over 3, which is 7 over 3, and 15 minus 7 over 3 will give me 38 over 3, and that will end up to be a sixth if we divide it. Okay, so you can do all of this on your calculator. Please make sure you know the difference between the ones that we need to factorize, and please know that we're busy with exponents where the exponents are variables, right? Okay, so this is just multiplication and division. Find the prime factors, do the exponent laws. Here there's pluses and minuses. Look for the common factor. Take out the common factor until we've got one term, do the division, and the rest is just calculator work. Okay, great. So I hope to see you again soon. Bye. This is your host Richard T, and thank you for joining us. Please visit our website mathsa.co.za for free guided exam tutorials.